Hello, good morning and good evening to everyone watching us live on YouTube across the globe. I am Ayush Patnaik, your host for the stream, and talking about myself, I'm the event organizer for Docker Mumbai community and a pre-final year student of computer science. So, first of all, I would like to express my gratitude towards my speakers, members, and all of the people watching it live on YouTube. So, for your consideration, please maintain the decorum and code of conduct in chat section of YouTube, and please be respectful towards the speakers. Today, I will be having three brilliant minds with me who will be talking about containers and Kubernetes, Dockerfile best practices, autonomous cloud deployment. Without any further delay, I will introduce the Docker Mumbai Meetup. Docker Mumbai Meetup community is a group part of 190 Docker user groups, and it comprises of 950 plus members and is growing day by day. So if you are a Docker enthusiast, cloud enthusiast, or a DevOps engineer and want to connect with people in your community, please do join the Docker Mumbai Meetup group. And if you're new to this channel, please subscribe. So, moving on, inviting our first speaker, Sayam Pathak, to the stream. He is the CNCF Ambassador, Director of Technical Evangelism at CIVO, and he is also the Docker Community Leader. So over to you, Sayam.
Yep. Thank you, Ayush, for inviting me and having me for the Docker Mumbai meetup. Glad to be here. I know it's a Saturday, but we'll try to make it a learning Saturday. So I'll share my screen. Okay, I hope you're able to see the screen. Are you able to see?
Yes, it's visible.
Okay, cool. So So today we'll be talking about containers and Kubernetes. Very interesting topic, obviously very close to my heart. We'll be diving into some of the concepts and it might look like a deep dive session, but I'll try to move from basics to kind of the deep dive ones. So a bit about myself. My name is Sayam Pathak. I'm working as Director of Technical Evangelism at CIVO, and you can find me on Twitter at that Sayam Pathak, where I tweet about all my work, latest technologies, and so on and so forth. So please make sure you subscribe, follow on Twitter if you want to have any of those conversations, and I'm very active over there. Blogging, yeah, it's there. Like, I'm a CNCF Portainer Traffic Ambassador. I'm a CK, CKAD, CK certified. I also run a Certs Magic show on Cloud Native TV, which is official Twitch channel of CNCF. Some of the other channels where I stream is sayambarak.com/YouTube, and you can see the upcoming live streams over there. So we have a WSL week coming up, where we'll be talking all about WSL, and then JS policy after that. I'm author of Let's Learn CK Scenario, which is based on Kubernetes security certification exam. And I also recently started a channel in my native language, which is Hindi. So it is sayambarak.com/cloudshala with my friend Kunal. So that's a bit about myself. And yeah, let's get started. So we will be talking about containers. But obviously, whenever we talk about containers, we obviously try to compare it, or try to have a similar view in terms of virtual machines. So Let's start by virtual machines and then move on to containers. So virtual machines are basically, in very simple terms, you have a physical machine. Now this can be your bare metal or a machine in cloud, and you have a hypervisor layer through which obviously you'll be able to create the virtual machines. Now physical machine is having your CPU, RAM, disk, and network. So all these things are there in your physical machine. Obviously you can think of your laptop as well as your physical machine, because it's actually it is having the RAM, it is having the disk, it is having CPUs. All these things are there, so you can consider your laptop also as a physical machine. Then you have a hypervisor layer over that, and you will be able to create the VMs. Now what are VMs? VMs are the virtual machines. You can call it as a slice of your physical hardware. So it's actually a slicing that is getting done. So a slice of physical CPU, slice of physical memory, and it will take some part of the disk as well, and it will share the network. So all these things are kind of slices. So VM is basically virtualizes the physical hardware in two different virtual machines. Now these virtual machines can have a different operating system. So the need was basically to have running multiple number of apps in different kind of environments, and you can have like Ubuntu over here, or any other operating system over here. So you can, like this, you will be having multiple virtual machines, but this is the actual slice of the physical hardware. So obviously when you talk about RAM and CPU and disk, they having some finite value, because they are not infinite obviously. So obviously the number of VMs that you can spin up on a physical hardware will also be finite in number. So that's how the VMs work. Now let's come to containers. So so containers are basically the representation of an operating system. So it is made to feel you exactly like an operating system. So you'll be able to look and feel like the operating system when you talk to containers. It will be having its own file system, it will be having its own memory address space, network space, user space. So all these things. So it is slice of operating system. So now what you have is, you have a physical machine or a VM. You have a physical machine or a VM. Obviously the VM will be having a particular operating system, and your operating system will be having a file system, like slash etc slash root and all those things. And it will be having a process tree, all the processes that runs, a network stack will be there, and the users that will be there. So same will be there in the same concepts are followed when it comes to containers. So when you inspect, or when you go inside a container, it will be having all the file system will be there. It will be having some memory address space, then network, which is each zeros. It will be having the root user. Obviously you can map it to the host user as a different user for some other purposes, but like this it works. So obviously like here here you need a hypervisor layer, here you need a container runtime. So we'll talk more about container runtime in the next couple of diagrams. So VMs virtualizes physical hardware, container virtualizes the operating system. So containers will be kind of a very similar look and feel to the operating system. Let's move on. Now here I go deep dive. So when we talk about containers, there are few concepts which are taken into consideration, be it any container runtime, which follows these to create a container. So these are Linux namespaces, control groups, and the union file system layers, copy and write. Most of your containers will adhere to, will be comprised of, or will be made from all these three building blocks. So basically Linux namespaces, kind of not very new concept, to be honest. Obviously Docker itself is not a new concept now. So Linux namespaces were there, and using the power of Linux namespaces, control groups, and the layers with which you can stack it on top of each other, there was something with which we can create a kind of stack that can represent a container, which internally actually represents a complete operating system. So it can slice down the operating system. So these are the namespaces. So the common, the most, I mean, these are the namespaces, so which are the process ID. So process ID for the container, and this is how it will look like in the container. So process ID will map to like a PID1. If you're familiar with kind of Linux concept, you already know that. So PID1 inside the container. File system. Each container also have a root file system. So this comes under the MNT namespace. Then we have the network namespace. So each container is having its own network interface, each zero that you might have heard if you have ever used containers. If not, then I'm telling you. Inter-process communication, process inside the container can, share the memory, communicate with other processes. So that is the inter-process communication, how it looks like in container. Then Unix and a time sharing system, UTS, which is like every container is having its own kind of identity, host name. Then you have your user. So basically, this is kind of not very straightforward mapping one to one. So you'll be having a root user for the container. So container will be having a root user, but it can be mapped to a different user in the host below. So this root over here will be mapped to a different user, can be mapped to a different user over Linux. So like this, your containers are partitioned. Your containers are isolated from each other. They will be having using the concept of Linux namespaces and control groups. Okay, you might be having a question like, what are control groups? So basically, a container also needs some amount of memory and CPU to run. Obviously, it is running a process, and a process would need a CPU and a memory to run. So all these resources and the are can be controlled by the controlled groups, which are called C groups, or it is basically just RAM, CPU, block IO. All these things are getting controlled by control groups, and also it is grouping the resources. Layers and union file system. So basically, when you run a container, so you'll be running, so there is a concept of image and a container. So you write a code. So all your code is packed inside an image. Then a running image is called container. So that's how it is. Now when you talk about containers, you can run multiple containers from a single image. So like you say, you have an Nginx image, and you can run container A from the same image, container B from the same image, container C from the same image, container D from the same image. But all these containers, obviously, like I told, when a container is there, they are isolated from each other. And if you change the HTML file of this Nginx image to hello and this to world, then they have to be separate. So basically, multiple writable layers. This is possible using the layered UFS system. So you have a unified view, shared stack, and each container has a writable layer. Although it is a single image which is shared, but on top of that, every container will have its own writable layer to which it can write to with respect to the changes that is made to that particular container. So if any change is made to a container, obviously the D will remain as it is. It will not write into the D's layer, it will write into the A layer. So that's how the layering works. Now, obviously, when we talk about isolation, it is not a perfect isolation. It is not an absolute secure isolation. So obviously, you have seen like security vulnerabilities. You have seen security scanning tools. You have seen a lot of things happening in the security space. So security-wise, there is a lot that you need to do. Obviously, it is isolated. Obviously, like I told you, if you write in container C1, it won't go to C2. That sort of things, the isolation, the process isolation, the network Linux namespace isolation, all these things are there. But there are security things which like running as non-root user. So prevent running from non-root user. You can use the security capabilities, which is called Linux capabilities. Then you can have your security signing of the images. Then you can have security at runtime level. So all these security layers, obviously, you have to implement on top of your containers when you build the complete production application. So this is what containers is: a slice of operating system comprised of Linux namespaces, control groups, and layered file system. These are the set of all the set of namespaces it is comprised of. PID, net, MNT, IPC, UTC, user. You will be seeing this a lot if you search or Google out things. Now let's talk about the most famous one, which is Docker. Obviously, it was originated from dot cloud. Dot cloud, it was, I mean, at that time, LXC was already there. So LXC is like the Linux containers were already there at that point of time, which were not as easy to set up a container, because you need to have, all these knowledge, obviously. And LXC plus AUFS, so dot cloud, they created something LXC plus AUFS with the help of, so LXC was basically your network namespace and cgroups, which I just explained over here. So these was LXC, and this plus your the file system, you will they created something called DC, I think, if I'm not wrong, DC. uh, After that, it was, it turned to Docker. Now in Docker also, they slowly and slowly removed the dependency from LXC and they moved to libcontainer. And I mean, after that, there are like OCI initiatives, which we'll just talk about. So Docker basically will be having a Docker daemon, so which has to be installed on operating system. So first layer is OS. So obviously, first is hardware, your physical machine, your OS, then you have a Docker daemon, then you have a Docker client. So basically, you have all the interactions that you will be doing is you will be doing through the Docker client. All the management that happens is via the Docker daemon or Docker D, which listens to the Docker APIs request and manage all the Docker objects. Now, Docker objects are basically the image, the containers, and all those things. So what basic things that you can do is like Docker pull Nginx. So you can pull an image. After pulling an image, you can run an image. So all these commands, obviously, I'm not going through because it is like introduction to containers. I want to explain the concept real well. So Docker pull, Docker run. Now when you do a Docker run, it is a container. And next is build. So you can build the container. Now obviously, someone will be talking about Docker files today. So you can write your Docker files, and you can build using the same Docker client, Docker build from this particular Docker file, and it will build out an image for you that you can run as a container. Now in that Docker file, obviously you will be there is like, you'll be copying the source code, or you'll be putting some of the files over there. So that is your source code. So there is a source code. You can build the image, and from the source code using Docker file, you're building the image, and then you will pushing it to a registry. So what is a registry? So registry is kind of a central place where you have all the images like Nginx, Ubuntu, and all those things. So that is a registry, centralized place for storing the images. There are multiple registries: GCR, Docker, QA, GitHub registry. So a lot of registries are there where your images are there, and each registry has its own, kind of features. And after from there, you pull the image, and you can push the image as well. So you'll be building the image, pushing the image, then you'll be pulling the image and running the image. So your code to build, to push, to registry, to pull, to run, this is a kind of life cycle of running a container from your code. So that's where Docker comes in. So everything in the registry is the images that are getting stored. Now when things were progressing, obviously there was an open container initiative, which is basically defining the standards, because as of now there are multiple container runtimes. All the container runtimes are expected to adhere to these standards. So like image spec standard and the runtime spec standard. So basically how the even Docker only contributed to most of these aspects, and they only started all these initiatives so that more and more folks can have you can have different container runtimes, but have a standard of that, like have a standard of image, have a standard of the runtime. So let's see. Yeah, this we'll talk a bit later, but let's see how a Docker container actually runs. So whenever you type Docker container run or Docker run, what happens is it talks to the daemon. It passes the request to the daemon. Now the Docker daemon doesn't know how to start a container. So this is I think this is a REST call that goes to Docker daemon. It doesn't know how to start a container. It forwards the call to container D. Actually, container D is a runtime, which you might be familiar with if you are familiar with the Kubernetes technology or Kubernetes world. But to be very honest, container D also does not know how to actually run a container. So container D is obviously a long running process. It manages the life cycle of a container, like which container dies, which container is there, and all this stuff, plenty of stuff. But it forwards this request to runc. So the actual component that starts the container is runc. Now runc starts the container. It's a short-lived process. So runc will start the container, and this is the person who is talking to Linux namespaces and all that, creating all your PIDs and all those Linux namespaces, C groups with the specific C group configuration that comes by default with the container runtime. So runc is the person who will be starting the container, and then this process gets killed. Now what happens, like how do the logs, how we can see the Docker logs or container D logs and all that stuff, and whenever the container exits or all that stuff, how do we know about that? We know about that from shim. So shim is a layer that is between the container D and runc, container D and the container, and this talks to the container D and telling like the logs, exits, and all that stuff. Shim is also a long running process. Now for each container, so let me make it clear. Like container D is one. You won't have, for every container you won't have a container D. Like you won't have different container D. Container D is single process, but for each container, you will be having a separate shim. For each container, you'll be having a separate shim process. So that's how it actually works beneath and behind the scenes to the Linux kernel level, to the Linux namespace level. That is how it works. So I hope you get a good view of till now what a container is. What how it is formed from Linux namespaces and control groups. You have an idea of how Docker actually came into picture, and you now also know how a container actually runs. Now, when Docker was there, Docker was not only to create the image and push the image. It also has a Docker orchestration, which is called Docker Swarm. So it was in the orchestration space as well. But that at that time there was rise of Kubernetes, which only focused on the orchestration piece, orchestration of the containers, and managing the set of containers, how they will run, how they will scale, monitoring them, auto heal, auto scale, all these features, fancy features of an orchestration engine. And it was meant for scale. Risen out of Borg and Omega projects at Google, born at Google, then they open sourced it, donated to CNCF, then you know where the CNCF ecosystem lies today, with n number of projects. I say n number because nobody has time to count that. So that's how the rise of Kubernetes was there. As of 1.20, the Kubernetes has deprecated Docker, means Docker soon in kind of 4 or 5 releases, I think. Docker won't be shipped by default as a container runtime with Kubernetes, so that is getting deprecated. But I think Mirantis will be supporting that, so that's a separate discussion. We'll not go into that. But now Kubernetes is there, and Kubernetes is the actual de facto standard for running the containers, for running your, for orchestrating the containers and your applications. Docker is still very well there to run your containers. Obviously, even 1.20 people are not running in production, to be very honest. People are still running 1.16 versions, 1.17 in their production, in their any of the cloud vendors as well. So it very well uses Docker. So Docker is very well in place. But Docker internally also uses containerd. So even if you move to containerd, it's okay because Docker internally also uses containerd. So it is actually, this particular piece is very lightweight. So obviously we need a lightweight solution with Kubernetes. That's why Kubernetes is a forward standard I feel would be there for any application that would be getting started. Even to talk about any distributions like RKE2 or K3s, they all are, or K0s, all are containerd based, because they know like it's very lightweight, it's very easy, and you directly can do most of the things using containerd. So now, just quickly, because we have around 5-10 minutes left, so I'll quickly touch upon the Kubernetes as well, Kubernetes architecture. So I told you like Kubernetes is orchestration engine. This image is taken from the documentation. So Kubernetes is an orchestration engine, and I will show you where Docker precisely sits over here, or where the container runtime precisely sits over there, and what is the use. So Kubernetes has a control plane, and also has some nodes, which are actual nodes where your workloads run. So your control plane and the worker nodes are there. So let's kind of zoom in a bit and see. So your control plane is having few components. The major one is obviously is the API server. So API server is the kind of brain. And whenever you use, so like Docker, you have Docker client. For Kubernetes, you have kubectl. So kubectl is something that you'll be using to interact with the cluster. And kubectl, whenever you type a kubectl command, the request directly goes to the API server. So API server is the one that your request directly goes to. Now, as soon as the request comes to API server, like, hey, okay, let me type kubectl run Nginx and hyphen image is equal to Nginx. So I told Kubernetes to run a pod. Pod is the smallest unit in a Kubernetes. So I told it to run basically an Nginx application on the cluster. So what happens? How this request is processed? So it goes to API server, and then it goes to scheduler. So API server says, hey, there is a workload that I need to run, which is Nginx image. Now, scheduler, obviously, with its scheduling algorithms, will see a lot of things. If you have defined any request resource things inside your um, YAML or specification, if the nodes present over here, because scheduler has to schedule your workload in one of these nodes, if your nodes has any dates, what would be the best fit node to run this workload? So all these things, and plenty of other things, scheduler will take care. Then scheduler will be assigning, pick one of the nodes. So let's say it picks this particular node and say, okay, here is the node where you can run your workload. So now the API server has the information that your workload will be running on this particular node. All the information, all the state of the cluster of the containers, everything gets stored in etcd. Etcd is a key value data store for storing Kubernetes state, and it only talks to API server. You can see like that. So it only talks to API server. So everything is getting stored in etcd. Now, in a node, there are few components like kubelet and kubeproxy for the networking. And kubelet is the person who's directly keep on talking to API server. Hey, API server, is there anything that I need to run? Hey, is there anything that I need to run? Okay, now scheduler told, run this particular pod on this particular node. Then API server tells, yes, there is one workload that you need to run. Run the Nginx pod. So kubelet says, okay, I need to run Nginx pod. Now kubelet has a component of CRI, CSI, and CNI. Now this is basically the container runtime interface, container storage interface, container networking interface. Now the most important obviously is the container runtime interface. On this particular node, you'll be having a container runtime. Either that can be Docker, Cryo, or Containerd, and so on and so forth. The kubelet will not run anything. Kubelet will just tell, hey, the container runtime, if it's Docker, hey Docker, run this container. And when we tell Docker to run the container, what happens? So this happens. So container, then the Docker talks to the registry, pulls the image, runs the container, and tells the kubelet, I have run the container. Kubelet tells API server, I have run the container. API server store the states of running container in etcd. That's how it works. So there are other components like cloud controller manager, which is basically for the cloud components, like the load balancer and all those stuff getting talked to the cloud controller manager. Then you have controller manager. So there are a lot of controller manager like replication controller manager, daemon set controller manager, deployment controller manager, and so on. So if you create a deployment with replicas of 5, means you want to create Nginx pod with always 5 replicas of it running, then it is a responsibility of deployment controller manager to always keep 5 copies of your pod running, of your container running in the nodes. So even if one pod goes down, it will automatically create another one. So that's the power. It automatically, if for any reason your pod exits or your pod deletes, gets exited, your deployment controller manager will create that. As simple as that. So you know all the components over here, you know all the networking pieces. So this is basically for the IP table setup for the networking, node to node networking. If you create services, it will populate the IP tables and so on and so forth, so that all the pods can communicate with each other, all the nodes can communicate with each other. So that's how the Kubernetes architecture works like. And I hope you have a fair bit of idea by now what VMs are, where containers stand, uh, where the containers stand, how a container is formed from Linux namespaces and control groups and layer of the file system, and how Docker came into the picture, how the Open Container Initiative is there, and how actually a container runs when you run a Docker container run command. Then how Kubernetes came into picture, what is Kubernetes, what its architecture, how if you run a command kubectl run pod -f image Nginx, what will happen, where the request goes, where everything happens, which thing actually runs the container and it actually runs the pod, and where does the state get stored. So yeah, I'm about time, and that's pretty much it that I had from today's presentation. I hope you have some amount of knowledge on the containers and containers, Kubernetes, how it works. Obviously, there are some of the resources that I'll be sharing in the chat. HTTPS co.com/academy. So I usually have just shared a link in the chat. So this is a Kubernetes course. So if you want to learn more about Kubernetes, this is a Kubernetes course that is created by myself. I originated that. Obviously, it has some of the other people on my CMO team as well who have recorded some of the sections. So this course will walk you through all the concepts of Kubernetes, how it works. I have worked really, in kind of deep in the volumes, like how the Kubernetes volumes would actually work, and some of the core concepts over there with a lot of examples. So make sure you check it out. The best part is absolutely free. You need to sign up on co.com. No credit card is required to view this course. So even if you sign up and you are asked for a credit card, that is only for creating resources on CO, not for viewing the academy. Viewing the academy is absolutely free for anyone. So make sure you use this and learn Kubernetes from me. And yeah, make sure you check out my YouTube channel, because that's where I keep on doing tons of stream daily. So it's basically like sayamlarger.com/YouTube. I have given the link to Ayush for sharing. You can check out the YouTube channel. Obviously, it's have tons of resources. More than hundreds of videos are there on that, and I keep on talking about the latest open source tech from the maintainers and the co-founders. So very interesting to see and hear from them always. So yeah, Ayush, I think I'm done for my session. So I have talked about containers and Kubernetes. Hope it was helpful. I'm ready to take any questions if there are any. So are there any questions, Ayush?
I guess there are no questions in the comments.
Okay.
Oh, I hope that will be fine. And that was a very informative and interesting session by you. Thank you for attending the stream and sharing your knowledge and experience with Docker community of Mumbai. Thank you.
Yep. Thank you for having me. It was a pleasure to be here. Bye all.
So that was a very okay. We have a comment. Yeah, Sayam, we have a comment by Jyoti. Let me, yeah. So she asks how much time it takes to learn Kubernetes and making first contribution.
Uh, Very simple answer is like I'm still learning Kubernetes. So even if I'm, I have a lot of experience in Kubernetes. I have done all the certifications. I'm still learning because it's kind of vast, and CNCF ecosystem is vast. But to contribute, you obviously need to know some amount of Kubernetes. So the course that is there on CVO, it's 5.5 hours course. Sorry, yeah, 5.5 hour course. spend that time. Enough knowledge is there to contribute to Kubernetes. Obviously, if you want to contribute code wise, you need to know Golang, Go programming language. So there are various resources on my channel as well, and there are various like Goofer Labs is there. I think Sangam should be here somewhere, so he can share some of the resources on learning Golang. Golang is there if you want to contribute code wise. Non-code contributions, check out Kunal's couple of videos on non-code contribution to Kubernetes from the contributors themselves. So there is documentation, there is other pieces where you can contribute to different amount of SIGs that are there. So tons of contributions opportunities are there. So I would say like learn Kubernetes because that's very important. You can also be part of the release team on Kubernetes actual release, how the actual release works, how the testing part, how the actually testing things work. So there are tons of releases, tons of SIGs that you can be part of. Obviously, I cannot go into deep dive it. I can talk about hours and hours for that, but spend some time in learning Kubernetes to understand what the ecosystem is, what the landscape is, understand what CNCF is. There are tons of streams on our channels that you can definitely check out. And this course that I've just posted is actually from my experience, what I have learned, what is missing out there right now, and I have tried to fill the gaps over there. So make sure you take that. You will have all the knowledge to prepare for certifications, all the knowledge to contribute to Kubernetes. Obviously, it doesn't cover any Golang. So I'm assuming if you have Golang plus this course, you are all set to contribute to Kubernetes in any way.
Thank you. So there's another question by Imraj. Yeah, he's asking if it is a wise decision if we switch from web dev to DevOps.
Why not? I mean, you can do. So it's not something like DevOps is just learning of some tools and it would work out. Basically, as a developer, also there's a certification also like CKAD, which is Certified Application, Kubernetes Application Developer. So as a developer also you can learn Kubernetes. So if you want to if you want to switch to SRE or a DevOps person, it's completely fine. Obviously, it's very hot job in the market. The pay scale is very good and all that stuff. But if you want to continue programming, if you love that, then you can do side by side as well. So you can know the concepts of Kubernetes and you can still code. People do code. Obviously, the people who are actually building the software, building these CNCF products, they know Kubernetes well, and they also are creating with the coding programming language. So it's completely okay if you if you learn both side by side. If you completely want to switch, I would say that is completely fine as well. But make sure DevOps is kind of not just learning a couple of tools. It's basically learning the whole process. It's basically learning the whole culture. You need to understand how the software lifecycle actually works. You need to understand how the software build, deploy, ship, run, and all those scanning, security, all these things work. So there is a complete like DevOps pipeline. There are a couple of books I would recommend. First and foremost the Phoenix Project. So make sure you read that book if you are just entering to the DevOps world, because that is an absolute gold book. The Phoenix Project that will help you to learn about some of the terminologies, concepts, and all that stuff. But definitely, if you are switching on a career perspective, do that. If you do not like kind of programming stuff, do that. But I would say in DevOps also there are some, like you have to write shell scripts, you have to write some Golang code, depending on where you are landing the job, because each job in DevOps domain have a kind of different perspective. In a company, for DevOps, they might require knowledge of Docker, Kubernetes, Jenkins. In B company, they might require Terraform, Kubernetes, Ansible. So it depends on where you are applying. So know about the process, know about the tooling, know about the landscape, know about the technologies, but don't fix to specific projects. Try to keep learning every day. Obviously, the best way is to pick one project at least from all the domains, like from CI perspective, from CD perspective, from orchestration perspective, from build perspective, from scanning perspective, from security perspective. Choose one project and have a deep knowledge of that. Apart from that, you can have a small knowledge of other projects.
Sorry, I got disinterrupted. Did you answer this comment? Which one to learn first, Docker or Kubernetes?
Obviously, like it's a I know it's a very basic question, but I'll try to answer it in a way like Kubernetes is an orchestration system. If you have heard this stream, Docker is basically for building and pushing the images to the registry. So Kubernetes cannot do that. So you have to learn you have to learn Docker, or what containers are, what is Docker, and what are images, its concepts, how to build, push, run image, how to run stop containers, and then you move on to Kubernetes, because Kubernetes is orchestrating the containers. So it's not like you learn this or this. If you don't know what a container is, how to run a container, you cannot do anything with Kubernetes, because Kubernetes internally is running pods, and a pod is a set of one or more containers. Hope that answers.
Yeah, so moving on, we have another question. I guess this is the last question. What are the prerequisites before learning cloud tech?
Cloud technology prerequisites. To be very honest, a good question. Why? Because some people feel that it might be a very basic question, but it's okay. If you are starting new in the technology, basic questions are fine. So how I answer it after years of experience is, to learn any technology, you just need a laptop and a will to learn. That's it. And the resources are there online. Whether you talk about a cloud guru, whether you talk about YouTube, whether you talk about our channels, whether you talk about any of the free resources, Udemy. So there are plenty of resources. You just don't need any prerequisites. So you just need a laptop, an operating system on top of that. Either it can be Mac, Windows, anything, and then you move on to the proper domain. So how the cloud domain works is, you pick up any cloud, or you pick up any, I would say, yeah, pick up any cloud, and there are basic three components, which are storage, compute, and networking, which are kind of common across all the clouds. And then the cloud, they have their own set of services. So you should know what a compute is, you should know what a server is, you should know what Linux is, you should know what networking is. So all these basic concepts. I'm not saying you need to know everything in detail. Obviously, if you learn Linux and Linux networking, you can be a system administrator easily. You don't need to learn Linux networking in depth. That is a huge topic. It will take 20, 30, 40 hours to learn Linux networking itself. So don't go deep into everything. But for learning cloud, you need to know what a compute is. In that, you need to know what a virtual machine is. For that, you need to know what operating system is. For that, you need to know what Linux is. For that, you need to know how to work with Linux. Obviously, you have worked with Linux. You know some commands. Some basic commands are definitely required, like ps-ef, mkdir, cat, ls. You should know grep. I mean, all these commands are common. So make sure you know all the common commands. Make sure you have concepts. Concept wise, you know about Linux. Concept wise, you know about Linux networking. Concept wise, you know, like what is the OSI layer, TCP IP model, and you know about these things. So these concepts should be clear, just like you are in college. So these concepts are very much talked about. So don't just read the books. These are actually used when you talk about cloud, and it's, so you have to understand it, and this is the right time. Down the lane, 7 years after, you might think like, I wish I would have covered these concepts, not for the exam perspective, but for my learning. So make sure you do that now. Then it will be really helpful.
Thank you, Sayam. We have someone asking, can you recommend some projects for beginners where Kubernetes can be used?
So Kubernetes, actually, there are a lot of small projects. Don't be intimidated by Kubernetes. So there's the whole CNCF ecosystem is there. Pick any project that you feel like it is important for you to learn. It is solving a particular piece of puzzle for you. It is active in the community. The community is good, is awesome actually, of CNCF. So make sure you pick any one of them. Start attending the meetings. Understand the project well, and slowly you will be see the issues which are there, see how people talk to each other, see how people communicate for respective issues, see how people raise the pull request in GitHub, understand what Git is, what GitHub is, because that's a single source where that is absolute requirement. Yeah, on the prerequisite one, I would add Git, and GitHub is absolute requirement, because you need to know that. And my friend is there, like Kunal. He is my colleague as well, and he runs like a data structure boot camp. He's running that for 60 days. I think that's absolute gold, free of cost. Then you have my channel, which is purely based on cloud native technologies, the latest in tech. So if a technology is released a couple of days back, we do a stream today. So that's how latest it is. You might not learn it today, but down the lane, 3 to 4 years after, you'll definitely come back to the channel and see some of the videos which are only there on my channel. So which is very interesting. So I try to cover all the new things. Don't learn everything, but keep learning. That's the simple thing. Resources, yeah, for Kubernetes, please go to co.com/academy, pure gold for students, because it is, I have tried like from scratch, and I have tried to make it as simple as possible to as complex as possible, not complex but as advanced level as possible. So obviously there are a lot of other concepts and other things I'm missing because Kubernetes is endless, but for a base level, for starting, for contributing, for learning, for implementing, for creating clusters, that much Kubernetes is more than enough.
Thank you. So I guess that's the end of comments.
Cool. Thank you for having me. And if you want to reach me out, please follow me on Twitter. My DMs are open. Shoot me out questions anytime. I might be late to reply, but I will reply.
Thank you, Sayam, for joining us.
Thank you, Aish, for
So
having me. Thank you all. Bye.
bye, Sayam. So moving on in the event, we had a very informative session about containers and Kubernetes by Sayam sir. Now we have the next speaker with us. Let me introduce Sangam Birader. He is the developer advocate at Accurix, and he's also the Docker community leader and ambassador at Octato or Traffic. So, without further delay, let's hear from himself. Welcome, Sangam.
Yeah, let me share my screen. Is it audible?
Yeah,
Yeah. So here is my screen. Hope it's visible to you all. And
yeah,
so today's topic is Dockerfile. So thanks to Sayam, he cleared up so many things, so many basic things, so anybody can learn. And topic little bit I changed. I added something called security because I work in the security company, and it's really hot topic today to talk about little bit security practices also, and also a little bit about one of the open source project called TerraScan, which is a cloud native security tool. Anybody can use, Kubernetes user, Docker, Terraform, or any kind of like AWS, those who are using AWS, and all those things. So moving further, so hope I believe everybody know Dockerfile. How many of you know Dockerfile? So can you like comment if you know? Hope uh, you know the Dockerfile, how to write. How many of you know, like anybody comment? So I assume you know the Docker file, or I will end up the session. I will show the basics and maybe I will explain the basic. So let's move on the best practices. Before that, my name is Brada Sangam. I work at developer advocate at Accurix, a Docker community leader. There is a link to join if you wanna join, and there is my GitHub. A GitHub ID where you get a lot of resources around cloud native, the whole lab. You can learn, you can contribute also to the documentation. Basically, those are the labs for the student. So first, this is the Docker file. This is how Docker file, simple Docker file look like. And I want to tell before that what is the Docker file. And the basic Docker file is a text file, simple text file, which has bunch of command from the Docker, which performs some kind of operations to build the images, build the containerize the application, even maybe that is web application, any kind of application, no matter what. And you containerize that application and ship anywhere, run anywhere, and Kubernetes anywhere. So before Docker file, or let's say Kubernetes, the orchestration engine. So Kubernetes developers use the Docker, and Docker, the basic part of the Docker is Docker file, right? If you want to build own kind of Docker images, you want to build containerize your application, you need to know simple skill set for any kind of developer, web developer, cloud developer, any kind of developer, they need to know Docker file. That's why Docker file is so important to understand, and it's a very basic concept when you move to the container world. So this is how Docker file look like, and Docker file save as a Docker file, okay, name. And inside that you can write this code. So now little bit I will give an introduction what these commands are and what are the best practices now from Alpine? So you might, you're coming from the student background, or maybe you use Alpine. So go to the Google and just search Alpine. So Alpine is a Linux distro, just like Ubuntu, just like other Linux distros. So Alpine is very small Linux distro basically. So what it does from Alpine means that it's pull that image from the Docker Hub. So Docker Hub is nothing but similar to the GitHub, okay, where we store the repositories, and Docker Hub is where we store our images that may be a public or private, which has all the dependencies. So maybe you are a Java developer, maybe you are XYZ developer. So you, whatever dependencies you need to build that image or run that program after containerize or run a container, so you need the basic thing. So just like when we code something, we need a variables, we need a base image. So any kind of infrastructure, take any kind of servers, laptops, anything, what is the basic thing? You have learned operating system subject in your college days or diploma days. So so operating system is very important. So operating system, we need operating system to run anything, right? Hardware, then operating system, then whatever the application dependencies and a whole bunch of things. Now this Docker concept come into picture. Now from Alpine, in Docker Hub, there is a predefined kind of thing already, like defined, lot of defined images. Lot of defined images are there. So you can pull that images from the Docker Hub registry, and then you add into your Docker file what kind of image you need. So might be you are writing a Java program, then use that only images like Java images. I will show the end of the, or let me go directly. Okay, hope this browser is visible to you. So when you go and search Docker Hub, so when you search the Docker Hub, you get this link, right? So you get this link which ask for the some credential, but when you search here, so let's say I search Java, okay. Now when you see the Java, there is a verified publisher image. So when you click this is a Java whole your dependency. You don't need to install a kind of whole Java application or Java or whatever the tool or installation process. You don't need to install basically. It is the pre-built image directly from the Oracle, directly from the creator of that project. So use that image as a dependency. Okay, first what you need now, you need a that particular dependency, you need a operating system also with that. So let me little bit now, here is the application which is a node application, and it runs simple kind of application. Now from Alpine, so what is the Alpine is a Linux distro, simple kind of minimal, which is 3 MB. So always use a minimal base image. It means that you are reducing the size of the container, you are reducing the operating system size, and you use like what you need. So basically you are reducing the cost, reducing so many things, right? And now work directory, now you are developing some kind of thing, let's say app. Inside app you have this package JSON and this node, index file, index HTML, web app, or any kind of thing. So you need to define that this is my work directory, give up whatever the work directory, create a kind of folder, then copy this file from this work directory, whatever the app. So it will copy from that work directory whatever the file inside a container, and then run npm. Basically it's installing npm top of the Alpine, and then it's running the command called node index.js or whatever HTML. So basically for the writing Docker file, what you need to know first, so you need to know what is the sequence when you run the Java or Go application or any kind of application. What is the sequence of command you perform without Docker? So you write those command in sequential with few command like from work. This is the Docker file command. So use this and write in the sequence manner, and this is sequence is very important. Okay, first you need operating system, then copy that whole kind of work directory, whatever the file you need, then install whatever you need. So this installation is not going to install top of your Mac, Windows, or whatever application you are using. It's going to install inside a container on top of Alpine base image, and then it will perform that command. So basically, when you run this, it will start the whatever the uh, Node.js application. So always keep in mind, always choose a minimal base image, and base images available in Docker Hub. Okay, this is the registry. You just need to search what you need, what kind of image you need, what kind of dependencies needs. There are predefined, already built, totally like lot of images, and you also create a custom image, and you can also push to the Docker Hub registry on your own account. We'll talk in the last. So moving forward, now we install so many application. Let's say, how many of you know Nginx? Nginx is a kind of server, little server where it's run the kind of HTML file or web server, little bit smaller web server. So now when the we use like apk get update command, usually in the Linux. So it install the unwanted stuff. It installs so many caches, temporary files, so many things, unwanted cache. So when you write a Docker file and when you use this thing, you either use this command, remove that whatever the cache path. So but you need to know this path, right? You need to know this knowledge. But also you can use this flag called dash dash no cache. So it makes sure that it removes the whatever unwanted cache packages, and it will help us to reduce the size of the image again. Whole point is the reducing the size, reducing the cost, making lightweight and easy to run within a second anywhere on the any kind of. And where this is why this practice is useful, because today Docker support for the Raspberry Pis today, the smallest kind of computer. It support IoT devices. So it support basically IoT system also. So make sure that this practice will help you there when you install or build something, and you remove this kind of thing, because Raspberry Pi don't take too much load, right? It has like small RAM, small CPU needs, and all this stuff. So it will it will take too much CPU utilization, Docker, basically. So reducing that, you can use this kind of removing cache packages and all these things. And one of the thing is, as an engineer or as a practice, no matter anyone, so we install so many packages. When you install the maybe Ubuntu, we update apk update operating system, add the some package, add something. So when you add multiple layer of commands, it's create a multiple layer top of the base image. Okay, so whatever the when you run this thing, it will be like very like big image. And further reducing that thing, now you I have Alpine. Now I install the curl, Node.js, Nginx, and some XYZ packages, and then I copy the index HTML file from that whatever the Nginx thing, and then I expose the AT port. When I run Docker run dash it, and it will like run this image directly on AT port. So you can go access this HTML file top of that. So best practices here: remove cache, use this command, remove cache. Don't use a multiple like series of layer, because each line create a multiple one layer top of it. When you do a Docker build dash t, whatever the Docker file or image name you want to give, then dot. When you build, just check the screen. Okay, what's happening actually when you build that Docker file? So it's show the layers, catching, downloading this thing, building this thing. It will show the layers, how many layers. Or you can just go and type the command called docker inspect, whatever the docker image id, it will give the layer. Or take a docker history command, very quick, and it will show the layers, what using, what's happening. So don't put all this kind of command in sequence, rather use and. Okay, use this thing and remove the cache. It will be like minimal and very useful. So you might be now developing some kind of thing. So these kind of best practices lead you to the best security and so many things. We will talk that also. Moving to next, how many of you know the ignore git ignore file from the GitHub? Basically, when you build something locally and when you push that thing to the GitHub, whatever the repository, you add dot git ignore and you add the this kind of file. What I need to ignore from this my directory on my laptop, when I push those files, not going to push automatically. It will ignore those file, and rest of the file it will push to the GitHub repository. Same concept is here, which is dot docker ignore file. So why you need to use docker ignore file? Because when you use some kind of key password or run some kind of secret or unwanted files or environmental variables, so that time you don't push those things to the docker hub or somewhere publicly. Because when it's containerized, when you build the docker build dash t and use whatever the name of the image and dot, basically the docker build context to take all these things whatever the inside your working directory and push those file to containerize those file and ship it. So basically what happened, if there is a secrets environment or anything credential information are there, that will go inside docker file, and that will, because you see so many news today, this hack, you see the docker hub vulnerabilities, you see so many things in the production, or some xyz company like secret out, or so many things because of because of mistake done by the developer. They may be done some kind of mistake, and that's where, because of that, you see so many the so many like data is like openly the key is sharing, anybody can access those things, and hackers are there, they reverse engineer those things and take your secret and utilize for the crypto mining and xyz, or any kind of use. So make sure that use docker ignore file, just like dot git ignore, and you write whatever your docker file same. So it makes sure that when it's built, it will not push those things. So this is very important. So moving to forward, use slim kind of distro. So there are couple of, from the Google, there are couple of let me show you here quickly. So just type distroless images. Okay, and now when you search distroless images, you get one docker, one of git repository. Now you see distroless docker images. So you see this kind of distroless docker images, debian static java based. So use these images. Okay, use these images because this is very lightweight, and it's contain like kind of buster like debian buster with golang. So you don't need to install a kind of operating system base image and whatever the package, it come with like two in one package. Go with whatever your operating system and use this thing. There are so many things. So this is one of the, from the Google, one of a project, open source project, which give you a kind of minimums. Or there are few images which use the tag called slim or minimal. So if you search like ubuntu minimal docker image. Okay, so when you search, there is official like repository. And now if I open, this is the image, and you see the lot of tag here you get, like minimal kind of tag. So use this kind of minimal distros of the operating systems like Ubuntu and all. You get in Docker Hub, so many or search. So this is just like 150 MB something image. When you pull the Ubuntu image, it's more like 500 MB kind of thing. So it reduces so much like space or so much complexity when you build, or it's will more lightweight. So use slim variant of the images. uh, and now moving the forward, most of the images, whatever the Docker you run, basically Docker run everything as a root. Okay, it's at, it has no password. Basically, when you run Docker run command, it will not ask you for the kind of whatever the Ubuntu image password or whatever the thing. So it run directly as a root. Okay, so this is one of the security concern or the not a best practices when writer people. I've seen so many of the public images, but always use run user add, like whatever the username or the whatever the convention name you want to give here. It might be related to your Docker images or anything. So add a user, because if attacker or anybody want to access, it's need to pass that there is a user level kind of top of the root, there is some kind of user. So it's good for the security reason, and it's always a best practice to do this, no matter what kind of application you are writing. So do this thing, cut the root. uh, and moving forward, remove unwanted stuff. Okay, don't add unwanted commands or unwanted data or readme file, anything. So remove this thing whatever unwanted. So it will be lightweight and easy. Tag wisely. So now you might seen some of the images is tagged, which is like when you build images, you tag as a latest or version 1, version 2. So make sure that tag your images. Why you need to tag your images? Because when there is some problem, some issues in the production, or even CI/CD pipeline or whatever, so you will get to know in which version there is a default or there is some issues or problem. So this is very important. Tag your images. Let's say I'm building image for Java, that is my first version of Java image. So give a tag to the image or give a tag. So it is always a best practice as engineer. So do tagging is very good. uh, do not use the latest, because there are so many uh, like so many when you use latest one. So there is, again already explained, when you use tag, you get to know this is for this thing, this is for this thing, this image for this thing. If there is some issue in future, you get to know when you, but use latest. But uh, but Docker by default pulls the latest image if you are not giving. Okay, so don't do that. Always give a tag. It's good for the naming convention. There are in Docker file, there is bunch of the unwanted Docker files. Maybe accidentally you pull the give the name wrong or something. So it might be pulling some other dependencies, some other person's dependencies or public repo. So make sure that give a tagging, very important. And now you can store to the Docker Hub. There is a public and private registry. So when you do a public registry, there is a security kind of concern. There is no layer of security there. So do depends on what is your use case. Maybe you are working in organization. Maybe I'm working at Accurix, and I want to use that internal. I don't want to publish publicly. So there are so many bunch of distro provider, not a Docker Hub only. There is like Amazon Container Registry, Azure Container Registry. So many registries are there. So you can use those registry also, and you can build own local registry also. We'll see some other time. So use public or private. If you do private, it's more secure. Okay. So one of the practice is that what your application you are building or Docker file building, create a single images as for, let's say I have simple application which is MySQL and some Java or some anything which is talking about MySQL. So what I will do, I will put MySQL in some other container, and I will put another container or my front end in some other container, and I connect that container, because Docker itself give all the capabilities which already available in operating system concept. So you get whole kind of thing. So use this single kind of method, whatever you are building, create different. That's the typically microservice kind of, people are moving to monolithic to microservice. That is one of a use case of Docker. Moving forward, use linter. What is a linter now? So this is the tools which, when you install into, go to the VS Code, there is a Docker linter, very famous, or go to this link. Now, when you go to this link, when you write a Docker file in daily use case, daily for the daily use, it will give you the best practices suggestions, and it will help you this tool. Is it your Docker file is best practice or not? So use this tool. This is very famous tool of both, like very famous a Docker file. You can use both thing, and avoid the hard coding, because there is a lot of feature in the Docker file, Docker file commands. So one of these is argument. So this is just like when you program pass as an argument, kind of thing. So what happened is here. So now I create a argument called version, and I can pass this. When I build the Docker file, I can give the version 9, 10. So whatever the version here in the argument, so it will give a tag to that particular image, whatever the base image. So node 10, node 9. So you can, without editing inside, you can just pass here as an argument, and you can, this value will pass to the base image, and it will pull that node 10 or node 9, whatever the base image, from the Docker hub. So use this practice. This is very useful if you want to specific build a different kind of images and test so many things. So do this kind of practices. One of main thing is always good to connect with community, and if you are open sourcing your Docker file, always put a label version. So label is kind of metadata. So when you, if I write a Docker file, I build some kind of open source project, I did my like college project containerized, and I want to do open source, I want to kind of social networking. So you can give a metadata, who is a maintainer of this thing. If there is an issue in the community, those who people using your Docker file, they can reach out to you, or if they have suggestion for your project. So kind of collaboration, you can use this metadata. And you can also give version. This is my Docker file version 1, 2, 3. You can give metadata details. This is not a good practice, but it's good to add if you are probably doing something community work and you get recognized, or somebody want to reach to you. Now final, my favorite part is vulnerabilities. Now Docker file is the key of building images. Okay, and that those images, tomorrow or today, you are going to learn Kubernetes anyway. When you learn Docker, and then maybe you are learning Kubernetes or using orchestration engine to manage these all things. So now one of the major thing is security. So how can you scan these Docker files and make sure you are doing right practice, right Docker security benchmarks or Kubernetes benchmark. So at Accurix, I work at Accurix. We are a cloud native cybersecurity company, and we have one of an open source offering called TerraScan. Basically, this is a tool which give whatever you are deploying into the cloud or infrastructure or anywhere in production. Before deploying, we check security, and you don't need to install Kubernetes, Docker, or anything. Just you need to install a TerraScan tool. So I'm gonna talk a little bit around this, and then I can take some of the question. Before that, I wanna bring another buzzy concept. One of our open source project, graduated project from CNCF, and I wanna add more security because this is a future. This is a future of security. This is a future of security as code, right? This is one of a initial way of writing policies for the your cloud native app, no matter Kubernetes, Kafka, Linux, Kubernetes, STO, Invi, Terraform, whatever, like what kind of you can connect or integrate this tool with anyone. So this is tool or the project called OPA, which means Open Policy Agent. This is a kind of agent which check the what to accept, what not to accept. So basically, here is a diagram. If I'm a person, I'm requesting something to this Docker or something running on this infrastructure, my application or something. I write a policies. I tell this policy is written in one of a language. You might not be familiar with this language, which is Rego. So Rego is basically kind of a language policy, writing a policy. So you can write very easy language, I will say, just like writing a JSON file or just writing a small file which has environmental variable and some policy, what to allow, not allow, kind of thing. Now you write a policy. Let's say I have a Docker file. I write a policy. What best practices I want to do? I'm a security engineer. I did some best practices. I write policies for both whole thing, and I integrate these policies to check my Docker file is secure or not. So we use Rego at at Accurix to write our policies to secure our give a kind of service to the our user, maybe those who using Kubernetes cloud, Docker, whatever the tools, and we do the real kind of security check basically. So this is one of a tool. So let me show you what how actually look like and what we work and so many things. So a little bit I want to give a perspective of what is the Rego, how it should look like at Accurix, how we use it in the real time, this language, this project, and how it's relate to the Docker files or Docker security or Kubernetes security, name it, like any kind of security, Helm security, Terraform security, AWS, GCP, GitHub, whatever the security part. So this is our project. If you go to the GitHub, this is the link I will share end of this session. Let me zoom it. Hope this is visible now. And now this is a project. If you go to the Accurix or search Terrascan, so this is our project which detect the compliance in the security violation for the Docker, Kubernetes, Terraform before deploying your infrastructure. You can add this tool into the CI/CD pipelines or infrastructure. So whatever the Rego I think I talked about, you don't need to write those things. Okay, we have a security team. We do the security research. We hack, break things, and learn and do security best practices for you. And this is totally open source project. So whatever, whenever you use Kubernetes or anything, you can scan those YML file and get what wrong with your file or what wrong kind of practices you are doing, and you get like, what is the problem in this file or this Docker file, Kubernetes or any kind of technology. You get the description, what is the problem and which line number. You can go and improve your skill, improve your best practices. Yes, I benchmark my benchmarks and all. So little bit overview. So I written the small, very small security kind of in the Rego. This is a Rego playground. It's directly accessible from the browser. You can install also. So you can like this package play. You can give the environmental variable like other languages. Now deny message, warn if there is if somebody using the latest image, whatever the best practices I told you about. You can write policies for that like this. Okay, so now let's take the first policy. So whenever you use environmental variable, it will check that is there is password, secrets, key or access, API token, something which is you are adding into the Docker file. So it will give warn you that okay, this is the some kind of issue and you need to fix it. Okay, so we write these policies to secure your cloud native infrastructure, and let's say don't use add command instead, like looking for the add command, instead use copy. So don't use add command, use copy command. So this is one of the best practices. You can write own kind of like rego policies how you need for your application, or maybe Kubernetes or any kind of thing. So this is something we use, and when you evaluate this thing, it will give input, and it will give a data, metadata, and data for you what happening and what kind of violation and this thing. So go write your, this is very basic, anybody can learn. There is a bunch of tutorials on the website, and there is uh, to learn this language, because this is very big future. Let me show you. Okay, so this is the company behind creating this Rego language and OPA project. So these people have something called academy. This is the academy, so where you can go and learn. Here we go. This is OPA, and inside that you will get, this is free course. You can learn Rego. Okay, so now let's see, you learn Rego, you write policies, you can contribute to the Terrascan also. We have, if you go to the integration, let me check. Go to the integration. No, it's under package, and then policies, and then OPA. So here is a directory. Okay, so sorry, I'm into wrong directory. Okay, let me see. So we have integrated this OPA library with our tool. So whatever the policies we write here, we have a bunch of Rego policies here for the Docker, GCP, AWS, and we do a lot of best practices. This is how our, when you use Docker run command, and what is the best practices, we create this kind of policies, best practices. It will give you the this kind of command on the, when you scan this thing, this is a security issues there, and you can scan and do a best practices. So you can also contribute if you know the Rego language, and you can write own also policies for your own project. And let me move to the demo part now, I think. Let me see my VS Code. Is it VS Code visible?
Yeah, it's visible.
So let me make this kind of. So now I have two Docker files. One is Docker file, simple. Now before that, what you need to do? Let me. I think I missed something here. Sorry for that. Let me. Yeah, is it visible? Yeah.
Yep.
So this is a Rego file which written up best practices rightly on the Rego, and you scan this thing. And now I'm talking about how you can secure your Docker files with Terrascan. So if you have Mac, Windows, whatever the platform, we you can install Terrascan anywhere. So you install this command brew install. Brew is a package manager, homebrew. So which we release our Terrascan binary there. So you use simple one command brew install Terrascan. It will install that Terrascan init, which is which initialize all the our policies, whatever in the Terrascan best practices, Kubernetes, AWS, all kind of good stuff. And it, and then you, if you wanna do Docker file scan, use this command, terrascan scan -i docker. But before that, you need to jump into that directory. Okay, whatever the directory you wanna, your Docker file is saved. So now I'm into this directory called terrascan repo, and if I ls, there is a bunch of, clear my screen. Is it visible, guys? Is it
Yeah.
visible?
Yeah, it's visible.
So now if I do like Docker, let's say I have two Docker files. Okay, I have one Docker file. Now you can give a Docker file name as a Docker file.go also. Okay, if it's related to Go or Java. So like this also you can save the name if you don't know. This is a simple Docker file, not a best practice. I think I'm not a good developer. I'm also learning. So I have This is simple, no Docker file. Now I can scan this Docker file and let's see what kind of vulnerabilities and security issues are there. Uh, Basic command terra scan, scan dash I and Docker. Now when I scan this thing, it's give me the which file, this kind of violation report you get if you are a security engineer or like primary user of Docker. Ensure to avoid run with sudo. So when you give a sudo command, which means that you're giving a root access to the user. So this is not a good practice, and this is like highly risky, medium risk. This is a risk. Uh, so which number of line you want to edit? So this kind of report you get, and what violation and all the good stuff related security. Now I get like three kind of thing. Let's see 12 number. Okay, this is sudo. What I will do, I will just remove this thing. I will save my file and I will scan this thing again. Same command. Let's see, we had three vulnerabilities. Now we have two vulnerabilities, right? Now let's say I have two files here, a Docker file and Docker Go file, which is like I think best practices from the Docker website itself. I took from the Docker website. We will talk about that one also. So I have this file now. I want to scan this particular file, not a Docker file. Okay. Now you can do something like this. Same command I will give dash f flag and I will specify file.go. Now it scan that particular file. Okay. Now you see file name is changed. Now ensure that run sudo same command. I see there is a kind of this thing. I will just remove this thing. I just not want it. I just added to show you there is an issue how to rise and how to check. I will scan this thing again. Now you see, I think zero vulnerabilities. Now this is totally secure and best practices, and you can use and run into production. Okay, you can build now. So before that, I see so many developer they are not doing a security practice. Security is very underrated. But when you go and you work in big production, one mistake can lead to billion of rupees, billion of you need to pay so many money to the hacker groups, and security is way important. I think every developer or DevOps engineer need to learn security or think about this thing. Just writing and building application is another thing. Also, make sure that your application is secure and are ready to use into production, or that is very good practice, I think. So let's talk a little bit about more things. Okay. So if you go to the Docker, if you Google also, you get Docker best practices directly on the documentation. So this is a documentation where you can but why I am here, I'm gonna show something latest and something very cool which is Docker come up with last few days back, which is called Docker file here doc. This is new. Maybe you are using maybe you are using Docker file and you don't know this release. This is very new, just released in July. This is new build kit. Build kit is a kind of technology project under the Docker which build all the Docker images. Okay, this is very important build kit. Docker use build kit. When you run Docker build dash t tag, basically it's running this project, this GitHub project. So now new support here, doc support is here. Now you can add this kind of commands. Before there is no capability, but you can add this kind of thing to run more easily. Now these commands you can run kind of this thing. There are a bunch of practical like kind of stuff. Now you can run like whatever the script you can run here directly, Python script or whatever uh, thing. So it may give you capability to enable that bash commands and all that good stuff from the Linux, and it's really helpful for me or anybody those who want to optimize and automation. Might be this is the uh, new level of automation. You don't need third party tools or third party thing, and this is I'm really happy with this release, new release of Docker file feature, and it has bunch of you can use this thing. I think it's available. There is another project called mock file, just like to build uh, Docker images. I can talk more about that also. So make sure to give a gift star to this repo. This is like TerraScan. Make sure give a gift star so it in the community people can use more and give more like kind of publicity and more contributor to such thing. Give a gift star to this project. And one more thing, if you want to learn Go language, so there is Sayam bring this point. You want to contribute to the Kubernetes. So just don't I think learn the language. Now Docker is built in Go. Most of the there are like 50% of the project from CNCF built on top of Go and Go language basically. But I'm not suggesting you to learn Go. It might be you are good at some XYZ programming language. Stick with that if you want. If you want to adopt, you are the multi programming language learner. So use that. So basically, I have this lab called Gopher Lab, which uh, kind of attract around like 3,000 kind of tutorials, best practices, and written by me. And I have learn whatever learn I have added here. You can also contribute. This is just available on GitHub directly. So you can learn Go language. Anybody can learn. And if you are want to learn, in September, I am taking a free workshop across PAN organized by uh, Chandigarh University. It's 12-hour workshop I am taking live. Not a live coding, but I will come up with a program so anybody can learn no matter he is a programmer or she is a programmer or not. Anybody can learn. At least I can go through the syntax basic on this thing. I'm not gonna teach you the how to build your logic. That's your own thing you need to do as a student, as a programmer, or anyone. So this is a Gopher lab. You can learn Go language, and I'm building so many labs over the past decade. I'm building so many labs, and I'm creating so many labs. I believe that documentation is very helpful. Anybody can access this thing without logging credential or anything. Anybody can contribute to this if they want to learn GitHub or anything. You can contribute to this thing. But currently, I'm only building. So there is Rust lab also. If you want to learn language called Rust, I have container labs, GitOps labs. So basically, whatever I think which is going to be boom in the market, or anybody can learn easy way, no extra effort, get a job. So I want to just make sure that anybody can learn anything very easily, quickly, without going into the problematic complexity programming in the starting, but getting familiar with latest technology, because this is a future. uh, I see, if you see the Linux repo, there is new branch created in the Linux, which is Rust next branch. And now whole Linux kernel is rewriting some of the modules rewritten in Rust language. So I see there is so too much scope. Rust is similar to C and C++. So anybody can learn because you already studied this C and C++. Now I will take, and if you want to connect with me, you want to learn more about security and this thing, just go to YouTube at Accurix at our company channel. I started something called TerraScan Talk, where I shared the security related stuff, and I have a Discord channel called Kubernetes, which attract around 1,300 member. Join there, and if you want to attend another meetup, so Docker Bangalore meetup is hosting DevOps India. Basically, I'm organizing and Ajit is organizing this meetup, and we have 13 speakers all over the world. So you can learn latest tech at conference. You can speak with, ask directly question. Uh, and there is like basic, level, advanced, and intermediate also. So make sure you want to learn more about other project, what other people are doing, develop products, and the experienced people do join. Now I will take some of the questions. Feel free to
Maybe
ask
share
question.
these links in the comment, the TerraScan and your GitHub.
So this is a TerraScan link. I will just share with you. Let me share. This is a project. I'm sharing. Wait, let's move to the. Okay, I think I don't. I'm not. This is a kind of link, and if you want to connect with me, you need to go to the discord.kubedaily.live. Okay, so you can go to, like, if you see here, discord .kubedaily.live. If you go, you get invitation directly from me to the your. There is so many members, too much interaction going on, and whatever I do, Sayam do, all all kind of update we give there. So make sure to join this Discord channel. A very lot of contents are there, free courses, so many, like this is fully non-profitable. So you can just join Discord, uh, this kind of community, and get updated. Mm, that's it. Is there any question? I think I will just. I think that's it.
Yeah, yes, there are no questions. That was a very informative and detailed session from you. So, any questions?
Any question if you have related to anything, maybe go or anything you want to learn, happy to answer. I think anyway, I am there available at the rate Coop Daily on Twitter, or search on LinkedIn. I'm very active, or join Discord channel. I will share the link in chat. If you have any kind of question, feel free to reach out to me. Um, I'm happy to help you to learn your Docker journey or Kubernetes journey or cloud native security journey. Thanks a lot for this opportunity. Enjoy the next speaker. There is too much there. And make sure to subscribe to the Docker community channel.
Thank you
Thanks a
so much.
lot, Ayush.
Yeah. So, as planned, we will move to the next speaker. Introducing Pavel Skrzipek from Poland. He is the Chief Technology Officer of AI Investments Limited and Technical Director of Melodic. So, he will be talking about autonomous multi cloud development. Over to you, Pavel. Thank you for joining us.
Yeah, thank you for the invitation. It's good to be here. Let me share my screen and please let me know if you can see my slides. Just a second. Okay, can you see it in full presentation mode?
Yeah, it's visible. You can go ahead.
Good, good, good. Okay, so again, thank you for the invitation. I've seen that now you know how to make a Docker, how to build a container, so it's time to deploy the containers. But let's discuss the deployment not in the single cloud, because that would be probably easy. But I want to tell you about the possibilities of the multi-cloud deployment for many type of the components, not only Docker containers, and in the optimized way. And starting from the beginning, yeah. As you probably know, the cloud computing is currently the first choice for the deploying application, especially for the newly established companies, startups, and so on. But the cloud computing platform becomes more and more complex and complicated, and especially if we are talking about the multi-cloud deployment. So we have another category of the solution, which are cloud management platform, which allows for the managing application deployment to the different cloud providers and also has some additional things. We have prepared the paper which compares the cloud management platforms and their capabilities for the multi-cloud deployment. You can see this paper here below. And in this paper, we have a very detailed comparison of the cloud management platform in terms of the cloud orchestration support, cloud application support, and platform intelligence. Yeah? So we have done this comparison. I will briefly say what each of the category means, and after that I will show one of the platform which is developed by us, which allows for the multi-cloud deployment of the various type components. So cloud orchestration support. Yeah, we have examined the following things: multi-cloud support, support for different resources like virtual machines, Docker containers, serverless components, and other, support for the own nodes, on-premises node, support for various services, and ability to automate things. We have also checked ability to model the application, to lifecycle management, data management, support for the workflow, and of course containerization, and so-called platform intelligence, which the most important thing is the optimization of the cloud resources, but also monitoring, adaptation, event and data management, and offer discovery. Yeah. Based on that, we have prepared the comparison. I do not go into details. I will share my presentation and also give you references to the paper if you are interested. But today, I would like to tell about the Melodic platform, which is one of the examined platform, and it is also the project developed by our team. It was started in the Horizon 2020 Melodic project, and now some kind of the development is further continued in the Morphemic project. So what is Melodic? Melodic is a single universal platform for optimized deployment and management of application in the cloud, in the multi-cloud. It allows for the deployment of the virtual machines, containers, and serverless components, and support three leading cloud providers, so AWS, Azure, and GCP, and also all open stack-based cloud providers, and some more smaller cloud providers like one-step cloud provider, which allow to deploy application to VMware. And very important, Melodic is fully open source, so you can download and use. I will tell a bit more about that later. Why to use that platform like Melodic? The first thing is that probably it is the simplest and easiest way to use multi-cloud approach. The second, it is the unified way to deploy virtual machines, containers, serverless, and also big data stack to different cloud providers. The deployment is fully automatic. And last but not least, the automatic optimization of the cloud resources. I will tell a bit more about that later. Melodic is using CAML language, Cloud Application Modeling and Execution Language, which is one of the cloud agnostic modeling languages, but this one is very special one. It is based on the Tosca, so allows to model application, not to make just the infrastructure as a code, allows to model components, connections, and security rules between them, so not only the infrastructure, but also components and application. For the infrastructure, it allows to model the the requirements. So we are not selecting the exact resources, but to define requirements for the infrastructure for each components based on the specific metrics, constraints and utility function. Thanks to that, Melodic is able to optimize the deployment. And the very important thing is to know what is this best deployment. But before we go to that, we need to start with the metric collections. Yeah? So in the Melodic, the metric collection subsystem called EMS, Event Management System, is built in and allows for collecting metrics from the different cloud providers, different applications. And based on that metrics, we can, in flexible way, create the so-called utility function, which focus on the business value of the application. Metrics could both measure the technical parameters like CPU usage, memory usage, but also the business value of the application, like average response time to the user or time for the processing certain jobs and so on. Based on that, we are creating the utility function, which optimize some kind of the trade-off between the cost, performance, and availability. Because, for example, if we want to minimize the cost of the application, the simple solution is just not to deploy anything, because in that case, the cost will be zero. But usually we want that our application is doing something, so we need certain level of the performance and availability, and it requires some cost. Yeah, so this is this trade-off between the cost, performance, availability, and that can be modeled as a utility function, and Melodic will find the best deployment based on these parameters. So you can consider Melodic as your smart autonomic DevOps. And how it works. First steps are manual, so we need to model our application in Camel. We need to set initial parameters, and after that, the Melodic automatically calculate the initial deployment plan and deploy this deployment plan. So deploy application to the selected cloud providers and start monitoring applications, so metrics collections. Based on the values of the metrics and their thresholds, Melodic decides if we want to make a reconfiguration or not. Yeah, so this is a very crucial and special element of the Melodic to make this reconfiguration. If Melodic decides to make the reconfiguration, then the new optimal solution is, the Melodic is looking for the new optimal solution. After finding new optimal solution, the application is redeployed, so components are moved from the one cloud providers to the another. Except this, in the Morphemic project, we also want to add some additional, more advanced concept. And the first concept is the polymorphic architecture. So currently we are selecting the most optimal set of the resources, so number of the virtual machines, the type of the virtual machines, and so on. But in future, we will be also able to optimize the technical forms of the components. So we can decide if the given components should be deployed as on the virtual machines, as a container, or maybe as a serverless component or big data jobs. And we will extend the utility to be able to decide also based on the change of the application architecture. And the second concept is so-called proactive adaptation, because currently Melodic is monitoring the current values of the metrics like number of the users or average response time to the user, and based on that is making decision about adding or removing some resources. But in the Morphemic project, we want to go one step further, so we want to proactively forecast the values of the metrics metrics, the numbers of the users, the estimated execution time, and proactively adapt application before there will be a bottleneck or so. Yeah, because the adaptation takes some time, like 5 or 10 minutes. We need to provision new resources and deploy the application on them. So to avoid any bottlenecks in the application working, we want to do that proactively to provide as seamless experience for the user as possible. And how this work in practice. Yeah, I will show you one example of our use case application. It is the AI investments use case application. AI investments is a Polish startup which is building the machine learning AI based portfolio optimization, investments portfolio optimization, and AI investments is using the latest machine learning time series forecasting methods and also optimization methods in a very similar way to used by the AlphaGo and AlphaStar. And the goal of the AI investments is to optimize the investments portfolio to achieve the highest rate of return and highest Sharpe ratio. So typical business goal for the AI investments is to train certain number, let's say 50 forecasting models in a given time frame, like 1 hour, using, of course, as minimal number of resources. So AI investments want to optimize the use of the resources, especially that the machine learning resources like virtual machines with the GPUs are very expensive, both in cloud and if you want to buy this server on premises. So the optimization is a very crucial thing for the AI investments, and also is considered as the one of the competitive advantage to be able to compete with the biggest investments bank and investments companies. Okay, so that's the reason that AI Investment deployed the Melodic and also plans to deploy, of course, the Morphemic and the latest optimization tools. And we have this typical business goal, like training the 50 forecasting models in 1 hour using as minimal number of resources as possible. How it goes. Yeah, the investments analyst in the AI investments is starting the training, setting the parameters, number of the models, estimated time, and so on. And the training is started on the on-premises resources because AI investments already have some own on-premises resources, and they are available and the cheapest one because they are already bought, so marginal cost is near zero. But usually this on-premises resources is not enough, so Melodic is estimated time of the training on the on-premises resources, and if it's too long, and usually unfortunately is, then additional resources in the cloud are added. Yeah, and Melodic is selecting the most optimal, most cheapest, most performance resources for a given task. After adding new resources, the time is again estimated, and if it's too much, then additional resources are added till the enough resources will be added, and the estimated time will be in the given time frame, like 1 hour. Yeah. And after that, after finishing the training, all resources are removed, the cloud resources, to save the cost. Of course, the results of the training are stored also in the selected storage in the cloud, and the job is considered finished in time, and we have the guarantee that the budget is minimal. So as you can see, the idea and the approach is quite simple, but it has a very significant benefits. Yeah? And in terms of the AI investments, the most important benefits, as you can see, is the effective optimization of the resource consumption. And also it gives for free the framework for the scaling automatically the machine learning training. Yeah? So Melodic is able to scale automatically the machine learning training, and we can optimize the work efficiency in relative to the budget planned. So AI investments can plan the budget and do not exceed this budget, because it will be controlled by Melodic to not exceed this budget. And one additional sideways benefit is increased reliability of the application. So we just get the high availability, yeah? Because if one cloud provider is not available, there is some outage or so, then Melodic is automatically move these components to the another cloud providers, and the same goes for the failure of the on-premises architecture. Yeah? In that case, the Melodic is moving the components to the cloud providers. The cost will be higher, but the application will be still working, and the user at the end get the results in the expected time. And for the AI investments, the cost savings was quite significant, especially if we are considered quite young company, because the difference between the approaches, these hybrid approaches with the on-premises and cloud resources used only in peaks, is the most optimal model. You have the comparison here on the screen, and both models, so the cloud only model and on-premises only model, are the most expensive, and the difference is up to 175,000 US dollars in the 3 years perspective. Yeah, so the savings are quite significant. Of course, probably in reality they will be lower, but nevertheless, it is the very significant number of money which can be saved thanks to this multi-cloud and hybrid cloud approach, and it is based on the real savings thanks to that using and approaches. The second use case, which I want to mention, it is the genome research application. It is the application used by one of the Polish universities to research the genome data and to compare the genome data from extracted from a given person to the reference genome data. And this is a typical big data application. It is based on the Spark framework. And the researchers in this university is again starting to process the data and want to get the result in the certain time. Let's say again 1 hour. At first, the university infrastructure is used, but usually it's not enough. So again, Melodic is estimating time needed to finish the processing genome data and adding new resources, measure time again, and add resources again. Till the estimated time will be lower than expected by the user. And yeah, the processing data are finished, and after finishing the data processing, all of the resources are removed. So it is the very similar approach as for AI investments, but in the completely different domain. So if you have the application which process a lot of data or train machine learning models, then you can really save a lot of money using that approaches. Just to sum up how it looks and how the melodic is used. Yeah, the first step is to model application in this camel language, then to deploy the melodic platform by itself on the one of the virtual machines, then submit camel model to the melodic, deploy the application, connect to your application, and then just simply enjoy. Yeah. We also have some workshops or videos with the melodic in real life. Unfortunately, today, due to the time constraints, we are not able to make the demonstration live, but I hope maybe it would be possible on some of the upcoming meetups. And also you can download Melodic, here is the link, and start using by yourself. And also, as I said, Melodic is fully open source under the Mozilla public license. So you can develop Melodic, become the Melodic developer, or use the Melodic components in your own code. And if you found that interested, please check melodic.cloud website and follow us on LinkedIn, Twitter, and also Facebook. There are a lot of the information, technical documentation, videos, and so on. And welcome to use Melodic or even to develop Melodic. So that's all from my side. Please let me know if there are any questions or so.
Thanks for the presentation. It was very informative and innovative. We will wait for the
Yeah.
comments for 1 minute. Meanwhile, you can share the link in the chat section so I can give it in the comments.
Okay, good idea. Just a second. I'm just sharing the website. And I will, let's say, share the LinkedIn profile as well. So you can follow. And if there would be any questions, so please do not hesitate to contact us. We'll be happy to help.
Yeah, so I have shared both of the links. Anyone who wants to connect can directly go to the link and connect with them. So I guess there are no
Perfect.
comments as of now. It was a good PPT and a good talk by you. Thank you for joining us in
Thank you
Docker
very
Mumbai.
much for the invitation. Thank you very much.
Yeah. So moving on, uh, now I will be talking about how can you connect with Docker community. Let me share my screen. Just a second. Yeah. So, do you want to get involved with Docker? Any thoughts about what is Docker? How can you contribute it? How can you connect? So let's move on. This is the main website of Docker community where you can contribute to the Docker and get involved, be it learning, teaching, or contributing to the Docker. So, what are the ways you can contribute to Docker? There are different programs. The first is Docker Captains. So we can directly see it. Let me just take you to the website. This is contribute.docker.com. I guess this is, yeah. contribute.docker.com. We have total 6 ways here to connect with the Docker community. The first one is Captain's Program. So, as you can see, Captain's Program is a distinction that Docker awards selected members of the community. And those captains are Docker ambassadors. They need not be employees, and their commitment is what required for the Docker community. So, the next one is Community Leaders Program. What is it? Now, every community, every group of Docker has a leader. So the role of the leader is to empower and support the community, plan, organize, and host Docker events, and make the community grow and prosper. So the third one is the main one where you can contribute code to the Docker and content. So there are four ways. First one is you can directly contribute code to Docker, as Docker is completely open source. The second one is you can, if you don't know code but you want to contribute still, so you can go through the documentation of Docker and analyze if any bugs are there present or not, and you can contribute there. The third one is you can contribute to Docker blogs. If you are a blogger and you want to write something about Docker, Kubernetes, or cloud, you can contribute there. The fourth one is getting involved with the site itself, which is contribute.docker.com. You can contribute content here, and it will be reviewed by the leaders and added. So the next ways, community tools. So what are the different community tools you can use to connect with Docker? The first one is Slack. It's a community of 30K plus members, and it's still growing. And you can join this Slack channel by clicking on this button. So I have already joined the channel. The next one is social media. We have different platforms: Twitter, Facebook, LinkedIn, YouTube, where you can connect with Docker community and learn from the community. There is a forum, which is a public forum for users to discuss questions, anything you want on Docker, and you can connect with really good people there. And as every developer knows, Stack Overflow, it connects millions of Docker developers, so you can check that out as well. The last one is Docker Community Book. It is a book developed by the members of open source Docker community, and it is rather an open source book, so you can contribute content there and it may get added. This was community tools. Moving on, we have community events. So what are community events? The event you are attending right now is community event, which is organized by Docker community of Mumbai. So similarly, there are different events happening all over the globe, and you can attend any of them and learn a lot from the different speakers who come to Docker community. The last one is developer preview program. So what developer preview program is, you can sign up for this program, and if you use Docker in your daily life, you can test newer versions of Docker without getting public. So this was about the different ways you can connect to Docker, and there's a very good uh, place where you can get content for Docker workshops. Uh, for example, if you want to organize any workshop or event in your community or in your college, so you can come here, and there are different curated sections: Docker for beginners, Docker for intermediate users, Kubernetes. You can choose any of them and pick the topic, and you will get a agenda, your event checklist, prerequisites, and everything which is required for making the event successful. So please check this website, and you can also get in touch with the Docker community. Mr. Ajit Raina is the captain of Docker India, and he is a really good guy. You can connect with him on Slack, and also William Kuiviger is the captain, so you can also connect him with him on Slack. So this was Docker community. So as you may have, some of you may have seen in the poster that Mr. Ali Abbas Merchant was also going to join us, but due to some unavoidable circumstances, he won't be here today. So I guess this is time to wrap up the session. I hope it was informative and a really good session for you, and you maybe, and if you maybe want to ask something, you can post it in the comments, else I will end the broadcast. And if you're new to this channel, please do subscribe Docker community channel. It's a growing channel as of now, and I have also posted the link of Docker Mumbai community. It comprises of 950 plus members as of now, but we hope to make it grow and take it to 10K in the next year. So I guess that's all. We have no more comments. Thank you for your time and cooperation and making this event successful despite the challenges we are facing in this pandemic. Thank you all. Bye bye. Stay safe.